Welcome everybody. This is the third video on the first chapter of the Arena book by Skelton and what is simulation, corresponding to Unit 1 on our simulation course. In the modern day, we use computers to simulate, and originally we used to have to create our models from scratch, all the relations in the system regarding the location of the entity, whether if it's a person or a truck, and how long will interact with other resources, etc. would have to be coded in a very tedious low-level process. The languages that were used to create this code were Fortran, for instance. When you code at this level of detail, you have the most flexibility, but it's also likely that you will find yourself in a very long, tedious process of development. Later on, you have support packages, subroutines that has been created so these packages can just the code that you write can access certain repetitive type of skills or the repetitive type of routines, and those were some of the packages that were distributed in the 70s and 80s. Some models for simulation just use spreadsheet like I did in the second video, but while they are powerful and useful, it's also very easy to get into problems of inconsistency, because it's very difficult to audit all these cells that you have in Excel. Later, there was development to create simulation-specific packages like GPSS, SimScript, SLAM, and Simon. Some of them are still in use, and it was an effective way to build it, but nonetheless, it was still coding up to a certain level. Here you have an example of Simon code. Simon code is, in a way, the granddad of Arena. It used to be that if you want to write code, if you want to create a simulation program, the most simple simulation program would look like the ones you have on the screen. And you would have to define your processes with create, assign, and queue, and all these reserve words, and also you will need to define these entities and how they are, the nature of those entities in a separate file, and you need to compile both and then link them in order to be able to execute. It was a very tedious process, and also prone to errors, especially syntaxes and logic errors that stop you from developing in a fast-paced mode. So fortunately, we have made a lot of progress from those times. Then you have high-level simulators that are very industry-specific. There are high-level simulators just for industries like semiconductors, and they are specialized in obtaining results for the semiconductor industry, but you cannot use it for other purposes out of the realm of that area. So they have limited flexibility, and maybe they would have issues with validity because we cannot test them easily against other type of behavior of the system. Arena particularly, the claim in the book is that it is prepared to model different levels, and it's easy to use because it's its graphical interface and the embedded systems with statistics. And indeed, my experience with Arena is that the graphical interface is great, very intuitive. All you have to do is click on the icons on the left and drag them into the working space and connect them. And that will give you the logic of where the entity is coming and where the entity is going. And if you click inside each one of these icons, you would get a window that allows you to drill down into the specific of the model, allowing you to specify the parameters inside each one of these processes. So this is incredibly easy to do compared to the alternative of writing for hours lines of code. I can create a model in a matter of minutes and making sure that, absolutely sure that the system will run. So this is very powerful. Arena facilitates the immediate animation of the process as soon as you finish, and of course you can embellish it using other graphic libraries and connections to even other systems that allow you to make representations in 3D model also. All the benefits of Arena is that you can integrate the logic to the details that originally we had with Fortran. Now we can connect to logic that is very specific to our problem that we can code in Visual Basic. And also we can connect to external data sets. The tabs that you have at the left are very context-based bars in such a way that you don't have a long list of endless options, but the options that you have are somewhat linked together at the same level of granularity and its relation with the others when you try to build a model. So of course we will go into the details of these, but it's very powerful. Now having said that, Arena is not the only package. There are other equivalent packages that you can acquire. Maybe the institution or the company that you will be working with may have a different package. Here you have some examples, but if you look yourselves for possible vendors of discrete event simulation packages, you will find easily more than 30. And of course, you cannot learn all the packages. That's why in this particular course, I am avoiding just teaching where to click for this particular package. I am trying to teach what are the inner workings of the simulation package, because those will not change too much. The location of the button may change, but how the statistics are created, how the random variables are created, all those are pretty much shared regardless of the brand. I am giving you these links so you have access to these videos in PowerPoint, I mean Blackboard, or in this PowerPoint that it also will be loaded into the Blackboard. So you can watch these videos. They are only a couple of minutes long, very short each one of them, but really the graphics are jaw-dropping. And while the animations and the representation of graphical visual words is it's important, we should not lose sight of our goal. The fact that we can create animations or models that are faster to create does not necessarily mean that they are more accurate. The fact that we have this animation does not mean that they are more accurate. Even more, the animation may be misleading, because if you see something happening in the animation that is very rare, you might be starting to think that that's what's going to happen every time in your system. Or even worse would be the case of asking an ever more equivalent representation of reality in the virtual world to match the dimensions and the colors and the appearance of the buildings and so on and so forth. None of that should be really important. So what it's important is that this is an input sampling and output sampling based process. We need to account for the fact that in order to create these models, we need to know statistics for the input, and we need to know statistics to understand the output. And therefore, it is not about just creating a nice representation in a graphical form. There are packages that are designed for the 3D representation with the extremely realistic possibilities, but that's not the purpose of this software. What we're trying to do is to arrive to solid performance measures, and that allows us to make decisions. So that would be the finish of this introductory discussion about what simulation is. In the next unit, we will discuss queuing theory. Thank you.